Hello, this is John from caveofprogramming.com. In this and the next probably two tutorials, we're going to take a look at casting in C++. I want to get on to talking about perfect forwarding in C++11, but first it's useful to have a look at casting. So here I've got a parent class, and then I've used that as a superclass for two subclasses, brother and sister, which both extend parent. And I've declared two objects here of the parent and a brother. I haven't used sister and probably won't use that in this tutorial. So I'm going to get onto that in a minute. But firstly, let's revisit casting in C. So C, which C++ is based on, of course, has casting in it. So let's have a float here and let's output it with value. Let's output it with cout like that. So this is going to give us what we expect, hopefully. But if we wanted to output this, for example, as an int, or for some reason we wanted to cast it to an int, we can do this. And this comes from C, and it's also common in C++. C++ also allows us to use a version of this that looks a bit like a constructor. So we can put the round brackets, instead of putting them around int, we put them around the actual value. So it's like we're constructing a new int here. And this works in a range of situations. But C++ gives you some more precisely defined types of casting that can help reduce errors in your program. So probably the simplest of those is the static cast. So to make this work, we can type static underscore cast, and in diamond brackets there, we put the type that we want to cast to. So here, let's say we want to cast to int. We put int in there. So you can use static cast in most of the situations where previously you would have used the kind of C-style cast. Let's suppose that we've got a parent pointer here. Let's call it maybe pp, pointer to parent. We can set that equal to a pointer to the child, to one of the child classes, any one of its descendants, any one of its subclasses. So here I'm setting the parent pointer equal to the address of brother here, which is a subclass of parent, and that just works without any explicit casting, because polymorphism, the idea of polymorphism, is that we can use a pointer or a reference to a subclass in any situation where we expect a pointer or a reference to a superclass, which is exactly this situation. We might expect to use parent here, address of a parent object, but we're allowed to use the address or a pointer to any subclass. The other way around, it doesn't work. So let's say we have brother pointer pb, and we try to set it equal to the address of parent. This isn't going to work out the box. There are some situations where you might want to do something similar to this, which we'll take a look at. But if you actually want to force this to work, one way to do it is to do a static cast to brother pointer. And let's output the pointer here. Well, we need round brackets around this thing that we're actually casting as well. Let's output the pointer to check that we have got a sensible looking pointer. So we should see the memory address there. So if we run this, it does actually work, and we get a pointer that seems to point at a valid address. This is very unsafe, because of course all kinds of things could go wrong here with virtual functions, or we could just have some methods in brother which don't exist in parent, and then we could try to call them using this pointer, and our program will just crash. So usually you want to avoid this kind of thing, but sometimes you might actually want to do this. So let's say, for example, we've got a parent pointer here. Let's call it, I'm going to call it P for pointer, another P for parent, and then B, because I'm going to make it a pointer to a brother object. So we've already seen that that's fine. We're using a subclass where parent class is expected. Polymorphism guarantees us that that's going to work. Let's comment this out for a second. So that's going to work. And we could have now, let's say we've got a brother pointer, and let's call this pointer brother to brother. So this is a pointer of the brother type, which we're intending to point at a brother object. So obviously we can do this brother. That's straightforwardly using the pointer, but it also does make sense in this situation to point it at the same address as this. So we've got a parent type pointer there, but the parent type pointer is pointing at a brother object, so we can point the brother pointer at it, and we can call methods on it, and we know that they are going to work. Now this doesn't compile out the box, but if we use a static cast like this, we can say brother pointer in there, and we can cast it to the right type. And let's also output this pointer, because I want to see that it does have a valid looking value. And we find that it does seem to work. Now, of course, this is potentially very error prone, because what static cast does is it's purely a compile time thing. So there's no runtime checking. And of course, this pointer could point at a parent object and not at a brother object. So it could turn out later in our code that this is actually invalid. We might start calling brother methods, which don't exist in the parent there, and we might have this pointer. It might be pointing at a parent object, so those method calls will fail, or at least not do what we expect them to do. So this is dangerous, and we're going to look at a better way to handle this in the next tutorial. So the key thing here is that static cast is just a compile time thing that will get your code working in many situations, or at least it will allow you to compile your program, but it's up to you to make sure that what static cast is actually doing makes sense. There are lots of situations where you might use static cast, but one other particularly interesting case, which has a bearing on perfect forwarding that we're going to look at later, is let's say you've got let's use parent again here, and let's say we've got a R-value reference to a parent object. We can use this like this. So this is going to work. We're setting a R-value reference to an R-value to refer to an R-value. And don't worry about these yellow icons, they're just unused variable warnings. So that's fine. Actually, I've got to turn on R-value references here. So let's just do that. I'm going to right-click my project. You may or may not have to do this in your project. And I'm going to go to C++ build, settings, miscellaneous under compiler, and say -standard equals C++11. Okay. So now we're using C++11. And if I run this, we're fine, and the only warnings we get are unused variable warnings. But what if for some reason we want to set this R-value reference to refer to an L value, like we want to say parent, like that? That's not going to work, but clearly it could work. The objects are of the right type here, and we could use a static cast to make that work. So let's say parent R-value reference, and just cast that like that. So this is actually going to work. Just to prove the point, let's give this a public void speak, and let's say cout parent. And then using this R-value reference, I can quite easily just say p.speak. So this is fine now. If I run this, the errors are going to go away, and it actually runs. And that could be useful. For example, if you've got a function with a parameter type that's a R-value reference, and for some reason you need to pass a L value to that function, this could save your life in that situation. Okay, so that's it for this tutorial. And again, for practice, this is kind of a relatively minor thing, but it's a good idea just to check this for yourself. Try casting subclasses to superclass types using pointers and superclass to subclass. See how that pans out, and just check that you can use static class. And you might want, for an exercise, just to create a function that has an R value reference parameter, and check that you can indeed pass an L value to that function if you use a static cast when you pass the argument to the function. Okay, so until next time, happy coding.